Hello and welcome to another video. My name is Nick, and today we are going to look at intermolecular forces, specifically our induced dipole forces, also called London forces. Now, we prefer to call these London forces now because technically they're actually induced dipole forces, which is the long name. We just shorten it to London forces, but it's a van der Waals force. We'd done the previous two van der Waals forces in our previous two videos. And so now we're going to look at the final one, which is our induced dipole force. So let's look at two non-polar molecules. So this is what happens. We have two non-polar molecules. So it's non-polar and non-polar. Okay, non-polar and non-polar. Okay, so we remember in our previous type of van der Waals force, we had a polar molecule which had a permanently, say, positive side on that one and negative on that side. And so the positive would have attracted electrons. Now, in two non-polar molecules, what happens is you've got electrons in both. And we have electrons that are constantly moving around. They're always moving. These electrons are never in the same place. So because they're moving, what occasionally happens is you get an imbalance of electrons on one side of a molecule. And so say there's more electrons here. And what we now have is a temporary dipole. So now this side becomes negative and we've got a positive here. And then what happens then is that these then electrons then get repelled to the back and we get a positive on this side. And so let's just draw that quickly. These electrons are repelled to here. And so they're all over here now. And so you've got a negative on this side. And so what we now have is a very weak force called a London force. So this is a London force or an induced dipole. Okay, so let's just go through that one more time. You've got a non-polar molecule, the electrons are moving, they are temporarily on one side, and for that moment, you now have a negative pole, which then repels the electrons in another molecule adjacent to the other side, creating a positive pole over there, and so we have these weak London forces. And we can see why they're going to be weaker, because with a dipole, that was a permanent pole. Here, we've got very temporary poles, and so we can think of this as what happens in oxygen. Okay, these oxygen molecules, they're not tightly bound. It's a gas, kind of moves around, and, and so there's these constant forming of, so let's look at the oxygen molecules, which are our O2 molecules. And these electrons are always moving. And so you've got these temporary poles, these induced dipoles. And so you get this force. But now because the oxygen's constantly, the molecules are moving. And so we get these forces that are, now this force suddenly breaks. And then you get another force here between perhaps another dipole, and then that breaks, and then you have another one. And so these are weak forces. So you can think of it as, it's not a permanent, like a covalent bond, or like maybe a stronger ionic bond, or an ion dipole force. These are very weak forces that are occurring. And so it gives the nature of, if you apply energy, you're going to break these forces very easily, because it doesn't take much. So hopefully that helped. We've gone through all the intermolecular forces now. This is the ion-induced dipole. Hopefully I helped in explaining how it works and why it's so weak, but also why it does exist, because of those electrons that are constantly moving. This is the last chemistry video for now. I'm going to be going back to doing maths. So I've said coming up special requests. So if you have a chemistry question, just put it in the comments below, and I will do a video on that, I promise. The first person who comments, I'm going to do a video on whatever chemistry question they have. So if this helped you, please subscribe as well. Tell all your friends, like the video, all that good stuff, and I will see you in the next lesson. Have a great day.